you sure about that one?
First thing, you guys, I want you to do is take out your calculator and remember where your fraction key is. If you're using a calculator like me, my fraction key looks like ABC. Your fraction key might look a little different, but make sure you're comfortable with it. If you have a question, just let me know. We are going to be graphing this. It is x to the 1/2 power. And that might look very foreign to you. Anything raised to a power that's a fraction, you may not have ever seen that before in your career as a student. But we're going to address that today, and we're going to start doing it with using our calculator. So I need to do -1, because it's negative and it's got a power on it, I want to put it in parentheses, raised to the 1/2 power. On my calculator, to raise it to a power, I have to use the caret key. Unless it's squared, and then I have a squared key. Some of you might have, on your calculator, it'll just have a little open box next to it. Did you guys, make sure that you can find the key that raises it to a power. So I'm going to do parenthesis. I have to turn it on first, of course. I'm going to do parenthesis, -1, end parenthesis, and then I'm going to raise it to the 1/2 power, and I put it in as a fraction, 1/2 power. And then I will enter, and this gives me a domain error. That means that this is not an answer. There is no answer for that one. I can't get that. It's undefined there. Yes, Ty.
I got N and I got I.
You got I. That's an imaginary number. Yep, that's what shows up. Is that what you got too, Angela, and I? You got -1. Did you put your -1 in parentheses? And then your power on the outside of the parentheses? And it still gave you -1 as the answer? Oh, okay. Then I'm going to take a look at your calculator. Let's move on to the 0. So we would do parenthesis. Oops, I have to clear mine. I go parenthesis 0, end parenthesis. I raise it. Mine uses the caret key. Again, make sure you know which key you're using. I'm going to put my half in parentheses, so it's 1 fraction 2 end parentheses power. So I have 0 raised to the 1/2 power. I hit enter. This one comes out as 0. I got an answer on this one. Please, again, make sure that you guys are getting these answers. We're going to move on to the next one. That was 0 to the 1/2. Now I'm on 1 to the 1/2. So I do parenthesis 1 end parenthesis. I raise it to the parenthesis 1/2 power. And I get 1 for that one. Now I'm going to do 2 raised to the 1/2 power. And, ooh, that one didn't come out nice. 1.414. Okay, now I'll do 4, parentheses 4, raised to the parentheses 1/2 power, and I got 2. So now I'm going to sketch this graph. Let's remember how to graph this. These are points. That's the point 0, 0, the point 1, 1, the point 2, 1.4-ish, and the point 4, 2. So 0, 0, 1, 1, 2, 1.4, and 4, 2. Wait, does this look familiar?
What's that half rainbow thing?
Yeah, it's that half rainbow thing. Which one was that? Do you guys remember which one that was? It's the square root. X to the 1/2 looks like the square root of x. A little bit weird. So that means, again, x to the 1/2 is equivalent to the square root of x. Let's do the 1/3. Same thing, except for this time when I plug it in my calculator, I'm going to raise it to the 1/3 power. So I'm going to plug in all my values. So I would do parenthesis -8 end parenthesis, raise it to, I use the caret key, you can do whatever key it works for you. I'm going to do parentheses 1/3 power. -2. Anybody agree with that? Yeah, I got -2 as well. What do we get for -1? No. You got -1? Yep, that's what you should get. Maybe because you plugged it in right, did you make sure you put your parenthesis or your third power in parentheses? Oh, there you go. That would do it. Okay. How about 0? 0. How about 1? 1. And 8? It is +2. Yeah. So again, let's do these points. 1, 2, 3, 4, 5, 6, 7, 8, -2. -1, -1. 0, 0. 1, 1. 1, 2, 3, 4, 5, 6, 7, 8. It looks like the snake. Which one was that one?
Absolute value.
Nope. Absolute value is a V.
Number.
Yeah, you've got it in your thing. Look back.
That's right.
Which one was the snake? Cube root. Nice. That was the cube root. That was this one. So x to the 1/3 is equivalent to the cube root. Okay, so knowing that x to the 1/2 is equal to the square root, x to the 1/3 is equal to the cube root, what would you expect x to the 2/3 is equal to? Well, if we go on with this, keep in mind that the denominator gives me my root, and the numerator is going to be my power on x. So when I rewrite this problem, this would be the cube root, because the denominator is 3, of x squared. That's how those fractions translate. So this one would be the square root of x to the 5th. The top number is the power. The bottom number is the root. And remember, in a square root, we just assume there's a little 2 there. We don't have to write it. And so we can translate any fraction power into a root or radical form. So let's go on to the next page. Again, we can transfer any fraction as a power into a radical form. Now, they wrote it with the squared on the outside, and I wrote it with the squared on the inside. And the thing with these is, it doesn't matter. Do whichever one is easier to do. Maybe it's easier to find the cube root and then square that number, or maybe it's easier to square that number and then find the cube root. So whichever one is easier to work with. But if I translate it to numbers, it's sometimes easier to do the root part first and then raise it to the power. So this would be the square root of 4 raised to the 5th. The square root of 4 is 2. 2 to the 5th, I can plug in my calculator and get 32. Now we're going to translate these here as roots. And instead of using our calculator, we're going to use those things I have hanging on the wall. One is the perfect cubes that is next to Christian, and the perfect squares is up in front. So this is translated as the square root of 9. What's the square root of 9? I thought I heard 3. Yep. There's my answer. This is the square root of 25. What's the square root of 25?
5.
Beautiful. This one is the cube root of 64. That's the one where we're going to have to go over there and look by Christian. The cube root of 64. It is the 1, 2, 3, 4th box. Cube root of 64. It is the 4th box, so it's 4th power. And then you count them like the first one is 1, then you move to the right. That's the 2nd box. That's 2 cubed. So let's do it. This one. This is translated. This one's not, I'm not going to be able to get an answer for, but I can translate it. What does the 5 tell me? 5th root. So that means a little 5 goes here of x squared. The 5th root of x squared. Or again, I could write this as the 5th root of x squared. I could do it either way. Both of those mean the same thing. One is not better than the other. It's just when you're working with them, maybe it'd be easier to find the 5th root first. Maybe it'd be easier to square first. So let's translate this number. This is the cube root of 8 squared. The 2 gives me the power on top. So what's the cube root of 8? Got my cubes over there.
2.
It's the 2nd box, so this is 2 squared, which is 4. Up next I have the square root of 16 raised to the 7th. Eek. Well, the square root of 16 is what? Square root uses the front one, square root, 4. 4 raised to the 7th. Now I'm going to depend on my calculator. 4 raised to the 7th power. I use the caret key on mine to raise it to a power. I use the caret key. You guys might have a different key that you use. Either way, when I plug that in, I get 16,384. 16,384. Now, on any of these, if you feel comfortable, you can use your calculator to raise it to that power instead. So I could have just taken this problem here and done 8, put parentheses around it, caret, parentheses, 2/3 power, and you should get the exact same answer. So you could do either way depending on what you have available for you. So let's try simplifying some of these. Let's try simplifying some of these. If I have 8 to the 1/3, m to the 1/3, that 1/3, the rule we learned, goes to both of them. And then I'm going to figure out what 8 to the 1/3 is. Well, that's the cube root of 8 times the cube root of m. What's the cube root of 8. This is one we'll see a lot. It's one of them that's up there on our cube root. So that's 2. I can't evaluate this last one, so I'm just going to leave it as the cube root of m. I don't have anything that I can take out of it. Right, I don't even know what m is. Okay, how do we deal with these guys? Do you remember these? This was our most recent. Where are there more? How many more? If I don't see a power, I assume it's a 1. Where are there more? 1 is bigger than a half, right? Yeah. How many more? Well, this is like y to the 1 minus 1/2 power. So if I'm going to do 1 minus 1/2, 1 minus, got a glare on that, 1/2, I get 1/2. So this is like y to the 1/2 power. Well, I don't know what that is, so the best I can do is the square root of y. Final answer. Now, all the other power rules are going to be the same. How do I deal with a negative power? Who remembers how I work with that? It goes to the, if it's on top, it goes to the bottom. If it's on the bottom, it goes to the top. The 2 is not included because this is not in parentheses. So this is m to the 1/2 over 2. Is there any simplifying I can do? No. I don't know what m is. So all I can write it as the square root of m over 2, and I call that a day. Final answer. So some of them I'm going to be a little bit restricted on how much I can do. It's just going to be moving stuff around a little bit. The 1, I could write this as 1 times m to the 1/2, but 1 times anything is itself, so I just don't even need to write that. Okay? When I have bigger powers on powers, multiple things going on, I'm going to work it the same way. I'm going to bring this through. I multiply this. This is m to the 2 times 1/4 over 16 to the 1/4. So this is m to the, I'm going to take my calculator again because I'm not afraid to use it. I do 2 times 1/4. That's why we learn how to use these keys on here. 2 times 1/4 gives me 1/2. So this is m to the 1/2 over 16 to the 1/4. So I go 16. Again, I'm not afraid to use my calculator. I'm going to put 1/4 in as my power. I put it in parentheses. Ray already got it. 2. Excellent. Over 2. I can't write this any other way other than the square root of m over 2. Keep in mind, a power on the outside gets multiplied through. This is 2 to the 1st. So this is 2 to the 1 times 4, x to the, bless you, 1/2 times 4. And again, I'm not afraid to use my calculator if I need to. I don't need it for 1 times 4, but I might need it for,
That one is actually a really weird one.
this would be 1/2 times 4. Half of 4, 2, that makes sense. X to the 2. 2 to the 4th, I can figure that out. Ray already got it. 2 raised to the 4th. So 16x to the 2nd is my final answer. So we have one more add to our power rules that we're working on. Let's bring this negative power through. This is x to the 2 times negative 1/2 over 2 to the 1 times negative 1/2. So when I multiply 2 times negative 1/2, I get x to the negative 1st 2 to the negative 1/2. How do I deal with these negative powers?
Well, you gotta bring the things to the top.
I'm going to flip them. Yep. If it's on the bottom, it goes to the top and becomes positive. If it's on the top, it goes to the bottom and becomes positive. Do I need to write the first power? No. Can I rewrite this 1/2 power? Yes. Square root of 2 over x. So take your time when you're going through these. Flip it over and just kind of go through the back. These are your complete exponent rules. This just goes through every rule that we've talked about. All of the powers, all of the things with negatives. So when you're working, you can refer back to this sheet at any time. Product you add. Power out of power you multiply. When I have both things inside, the power has to go to both of them. It goes through every step. Quotient, you end up subtracting. When I have it on the top and the bottom, it goes through to all of them. What if it's a negative power? I end up flipping it. What was on the bottom goes to the top. What was on top? Here's a big one. Anything to the 0 power, 1. You'd have a whole lot of stuff to the 0 power. Anything to the 0 power. Here's again our negative rule, and then here's the fraction rule broken down. Those are what you're going to be referring to when you work on your homework.